Check. So, determine the length of CD, which is right here. That means I am working in this green triangle, which means I have theta of 32, hypotenuse of 16, and I need an opposite, so that is sine 32 equals opposite over 16, 16 sine 32, and that answer is 8.47. Most of you will have rounded it to 8.5. That's okay. Once I know it, I write it in. Number 2, determine the expression you would use to find CB. That is this one. The expression you would use. You have infinite choices. You could use Pythagoras because you now know the hypotenuse on that side. You could use cosine because adjacent hypotenuse. You could use tan because opposite adjacent. You could even, if you were really crazy, say this was 58 and use sine again. I don't care what you did, but the important thing here is you showed me your work. Most of you, hopefully, said cos 32 equaled A over 16, so 16 cos 32 equaled A, which is CB. Hopefully, most of you used cos. If you didn't, though, it's no big deal. What is the height of AC? That is AC. If this is 45 and this is 45, what do you know about this triangle? It's an isosceles triangle, which means the two legs are exactly the same. So this is 8.5. Of course, you could have done that with trig, but you can save a lot of time by knowing stuff about triangles. And the straight line distance from A to D was this right here. And of course, you could have done sine, cos, tan, not tan, sine, cos, or Pythagoras. And the answer was most people choose to do Pythagoras, which is 8.5 squared plus 8.5 squared. And that's going to get you 12. Of course, that's not the real answer. The real answer is 11.99 because those are not 8.5. They're 8.47293785 or whatever it is. But of course, when you show me work, I'm willing to give you full credit, even if your number is slightly different from mine. Airplane. Oh, this question makes me cry. Not just you, it makes me cry all the time. The airport is on the ground. Over here, there's the shadow of a plane on the ground. That plane is 37 kilometers north, because north is always up when we draw, and it is 81 kilometers east. Now, I want to know how far the plane is from the airport. Of course, I would not measure this. I would measure the hypotenuse, which is the square root of 81 squared plus 37 squared, which is 89.05. Of course, the plane is not on the ground. The plane is up in the air. Here is the airport. I'm going to erase this triangle. Here is the airport. The plane, if it were on the ground, is 89.05 away. But the plane is not on the ground. The plane is in the air. 6 kilometers, making another right-angle triangle. The plane would have to fly on this line in order to land. That's how far the plane would have to fly. So, of course, that is the square root of 6 squared plus 89.05 squared, which I can't remember exactly what it is. I think it's 83 or 89. I don't remember. But it is. That calculator doesn't work. 36 plus 89.05 squared square root is 89.25. Most of you will have put 89.3, which is fine. The angle along the ground. So, we are on the ground, 37, 81. I need this angle right here, which of course is shift tan. Shift tan of opposite 81 over 37, and that gets you 65. If this is 65 and I started going north, I adjusted 65 to the east, so it is north 65 east, which is, you learned how to write directions like that on page 56. Angle of elevation, that's this triangle, because it's the one going up, 89.05 and 6. You need that right there, and it is 4 degrees, because you did shift tan of 6 over 89.05, or 89.1 if you round it up. Height of the tree, right there. That is tan 32 equals opposite over 52, so that is 52 tan 32, which is, if I'm not mistaken, 32 and a half.
Yeah.
Total distance to the bottom of the canyon, well, you know this is 32.5, so if you know this, you're going to add 32.5 plus that. How are you going to find that? That's tan 67 equals O over 52, 52 tan 67, and I think that's 122.
Yeah.
So when you add it, you get 154.5. Two trees, one tree, it's green. Another tree, it's green. They're 100 meters apart. From a point halfway, as soon as you make a point halfway, that's 50, that's 50. Two angles of elevation, 8 and 13. I got tree X, I got tree Y. Which tree is taller? Y, the way I've drawn it here, because the angle of elevation is higher. So I need to do Y minus X, which is opposite over adjacent, so it is 50 tan 13 minus 50 tan 8. And I can't remember the answer. I think it's 8.1 or something. 8.5? Yes. 5 meters? Okay, thank you. It is 4.516. And I wanted this to the nearest centimeter, so it is 4 meters, 52 centimeters. On a test, that would get you full marks. 4.52 meters, I would even allow that. This question. First one, I start at Roberts Point, and I sail off at 16 degrees to Coal Island. Then over to Fernie Island, then back. Now, straight north is 0. I start counting at 0. I start counting that way. So I have this triangle, 16, and I know that Fernie Island, right there, is 1750. So all I do is use that to find the other two sides. No right way to do it. I could do tan to find this side. I could do cos to find the hypotenuse. Once I have the hypotenuse, or this side, I could do Pythagoras, or I could do more trig. It doesn't matter. It's totally up to you what you do. I personally, since this is a trig unit, always do trig. So the first thing I would do would be cos 16 equals adjacent over hypotenuse. So hypotenuse equals 1750 over cos 16. Would I go to my calculator now?
Yeah.
I wouldn't, because I got to add this all up, right? And I want the best possible answer. So I'm going to leave that. Here, this side is tan 16 equals opposite over adjacent. So O over 1750. So 1750 tan 16. And my final answer then is 1750, because I sailed this bit, plus 1750 over cos 16, plus 1750 times tan 16. And I believe the answer is 4,000 and something. But I'm not 100% sure. I'm just checking right now. It is, I lied, 3,000, that's 3,900. Oh, no, I did that wrong. I forgot to divide by cos. I multiplied by cos. Whew, good thing I checked. Divided by cos 16 plus 1750 tan 16. There we go. 4,072.3. Then down here, Curtis Point is north of Armstrong Point. So there's Armstrong Point, 800 up to Curtis Point. The sailboat leaves Armstrong Point and sails to Kingfisher Point. KP. Now, it says he left at a bearing of 307. Straight north is what? 0. We count clockwise. If I go all the way around, I've played enough Sean White. How far is that? I'm facing north right now. If I turn all the way around, 360. I only turned 307. So what's left in here? 53. All the way around is 360. I turned 307. So what's left in here? 53. Now I use that to find all these. It's the exact same question. It is 800 plus 800 over cos 53 plus 800 times tan 53. And the answer is something like 3,190 or something. $3,190.1. 0.95 if you want to go crazy. Or 3,191. Again, I don't care. I will hold on. But we are running out of time and it is recording. This question is very similar to the airplane question. I need this height right here, which means I need 2 pieces of information on that purple triangle, of which I only have 1, 43. But this side right here is part of this triangle. And that orange triangle, I have it, oops, I don't want to use my thick felt. I have a theta of 69 degrees, and I have an adjacent of 30. This side here is that side. So, tan 69 equals opposite over 30. So 30 tan 69 is this side right here. I need this side up here, so that is tan 43 equals opposite over adjacent, which is 30 tan 69. I got this on the bottom, so it's 30 tan 69 times tan 43 to equal our height. And I think it's 72. Times 72.88. Microwave tower. There's the tower. The anchor point of one guy wire is 9.8 from the base. So there's a wire that goes like this. 9.8 with an angle of elevation of 37. There's another wire that goes to the top, and it is 58. It is also 9.8. I want this number right here. So that is this whole purple side, which I will call X, minus this whole brown, or it's supposed to be brown. this brown side, which I will call y. So I need to do x minus y. So that is opposite over adjacent. 9.8 tan 58 minus 9.8 tan 37 to get an answer of whatever it is. $8.3. And lastly, a suspension bridge. Suspension bridge is like all the bridges around here except the Abbotsford Mission Bridge. There are 2 towers and there are wires. We know that those wires are 10.8 and 18.65, and I know this is 135. So I use those 2 triangles to find x, then I use it to find y, and then what do I do with that answer? I add it, and then what do I do with that? Multiply by 2, because the bridge is doubled. So that is opposite over adjacent. That is 135 divided by tan 10.8 plus 135 divided by tan 18.65, and all that multiplied by 2. And the answer is 2,215.4. Or 36, or 37. So, it is 9:07. You have this from which to study for tomorrow. Tomorrow you will write that open book trig test. You will get it back on Monday. That will be what goes in for your trig review. Tuesday you will write your actual trig test. You wascally wabbits, you will write your actual trig test. For the which question? Because that only covers half the bridge. No, the towers of the bridge. Yeah. These 2 towers. What? But a suspension bridge has wires hanging from it, like the Port Mann Bridge, or the Alex Fraser Bridge, or the Lionsgate Bridge, or the Golden Gate Bridge. Okay, I understand that. But so you draw it, and you show me work, and then I decide if you did the trig right or not. You're not getting credit for drawing, but I did give you this overnight. So if you didn't know what a suspension bridge looked like, what could you have done? I understand that. I understand that, Sam. But I'm saying, what could you have done to make sure you drew it right? Right. Every year, less and less kids know what a suspension bridge is, so I probably have to get rid of this question. Or, no, I know that, Sam. I'm just saying. That's what I'm saying. Less and less kids know that. So what I got to do is now, right here, I got to add in to this definition, just like the Port Mann Bridge, the Lionsgate Bridge, the Alex Fraser Bridge, the Golden Gate Bridge, the Pitt River Bridge, and all those bridges have 2 towers and wires.
Do you think kids will still ask what are those bridges?
Yes, they will. But I always give this for homework. So whenever you are not here, even when you're here, all of you have access to every single piece of knowledge ever in the history of humanity, all held in your phone. You just spend all your time Snapchatting instead of using it for finding information. There's a big difference, right? This could get me to the moon. There's more computing power in this phone than all the computers put together that got humans to the moon 50 years ago. There's more computing power in this calculator than what got humans to the moon 50 years ago. And yet, which is kind of weird, right?
And calculators don't seem that complex.
Well, calculators aren't really computers. Everybody talks about calculators as being a computer. They're not really. A computer can be programmed to make decisions. A calculator can't.
It's just whatever you say.
A calculator is just that, a calculator. This thing is essentially, you know those things old guys counted on? The abacus that slid the beads across? That's all this is. And there are people that are good with abaci that can do work on an abacus faster than you can punch it into here. Yes. Google abacus expert. You won't, but those things that you use to count with the beads that slide across.
How would you I get if you're organization of things.
You can multiply on an abacus, you can divide on an abacus, you just need to know what you're doing. The very first computers were basically automatic abacus. Abaci, yes. I didn't want to say that.
Can you show us something